So I am from American Packaging. We've been making packaging for over 115 years. Going to talk a little bit about how we use data, and everybody keeps talking about the digital twin. I don't think of exactly what we do as a digital twin, but it's developing one. We started collecting data from equipment with one machine in 2012. It has since went to over 100 machines in what will be 6 facilities in June. We use quality, downtime, life cycle. We're looking to use sustain. We use monitoring and recipe management as critical parameters around how we run our business. Good examples of what we do, you can see quality management on the left. We send information to our service, EI3. It loads in the quality test data that they need to fill based upon our product specs. They test the data. We auto-generate COAs. We have recipes that are based off of our product specs that we can use to track, are they running it to specification? If they're not, we can alert if it's a critical parameter that would cause a failure, or if it's something that's more of, it could be a maintenance issue, we can track that. With that, we do automatic downtime tracking based upon parameters off the machine. So for example, we have slitters that run material. We know what a set change looks like on the machine. We know what a master roll change looks like. We know what a splice looks like. So we can take that in, generate automated downtime reports, so then we can see how people are performing to standard, how everything is going. If there's problems, is it a specification problem? Is it a machine problem? Or is it a training problem? And then you can see some of the analysis results, like when we have a real long downtime, we can go help understand why that was. Were they working on a maintenance problem at the same time? Oh, back one. On the left, you can see one of our COAs that we've generated. And then on the right is essentially the portal overview. That's all of our equipment online. So a big part of why this is so important to me and why I care so much about data is that it's all the data that I need to make any decision whenever I need to make it. I can see it, I can use, and it's holistic. So our quality feeds back into our process monitoring. Our process monitoring feeds into downtime. Everything needs to be feeding into the rest of the systems. We don't want any of it siloed. One of the big projects that we have going on right now that we're working on is predictive analysis of failures on our lamination lines. And we're looking to move it across to others, but currently we are doing it on the lamination products. We have 4 laminators that this is currently on. They're all the same model essentially, so we can aggregate all that data and see if a failure on one machine in Iowa looks like a failure in Wisconsin, looks like a failure in New York, and then help prevent and predict that failure in advance. So this is the model that we're essentially using for that predictive analysis. We did the Explore. We had a monitor put on. We looked at some potential issues. They did a characterization of the machine when it was believed to be healthy, assess if they can see potential problems, and then we took it further, installed the sensors on multiple machines in the same location. One sensor per machine has worked. We've actually looked at putting 2 on the equipment, so that way we can get a strength signal and kind of do some work to triangulate where the issue would be. You'll see the business value that we've seen from it, and then how we're looking to, again, kind of can carry it across to other pieces of equipment. So this is a lot of really impressive writing that somebody did about data analysis and everything. So you can see kind of the bearing or the machine running parameters. If you stop by EI3's booth, you'll actually see a graph that looks a lot like that. Go through and I'll give you an example of what ours looks like. So this is looking at continuously recorded vibration patterns on a bearing, and so they can find bearing deterioration and bearing failure. And then you go and see this is actually from our machine. and you can see kind of the same thing. We saw a real-world failure that began 4 hours before it actually failed. So the question is, can we start to push that back even further so we can do predictive maintenance and then prevent it, make sure, again, that we're holistic. So if we tie it into our maintenance management system, we can make sure we have the parts on hand, we can schedule the downtime, we can do all of the necessary things to make sure that this becomes a scheduled prevention instead of a 12-hour downtime event. We'll get into it. So monetary value, we talked about kind of what this equated to for us. We see approximately between 16 to 20 bearing failures per year, depending upon what we're doing. Some of it's in pretty harsh for the bearing environment. The Symphony analysis provided 12 hours of advance warning. Again, look to continue to push that back further as we learn better what a bearing failure may look like. We could have saved that downtime if we had looked at noticed the warning, had the alarm, knew we had the bearing on site. So when you look at that, it's about approximately 150 to 200K a year in savings. And that's just in these particular failures. There's a lot of other instances that we've looked at using this for. And again, connecting up other sensors and other things. We have 500 data points for some of these things that we're looking at. That's it. I figured brevity was important, so.